Good afternoon, everybody. It's 5 o'clock on Tuesday, which means it's time for math. My name is Jeremy Jasper with KathleenJasper.com. And just like we do every Tuesday from 5 to 6 p.m., I'm going to do some math problems with you to help you out on your teacher certification exams. So welcome, everybody. I had the week off last week, but we're ready to roll right into it this week. There's a little bit of storm rolling through here, so you may hear some thunder, and hopefully I don't cut out and we don't lose power. But other than that, we should be good to go for the next hour. And just like we do every Tuesday, I'm going to do 10 problems on our Facebook page. We are live, as well as our YouTube channel. We are live. The problems that I'm doing are right below. If you look in the comments below or right below the video, you'll see that there's a link, and on that link you will be able to download the PDF of my 10 problems that I'll be doing tonight. And so sorry, I'm just trying to make sure. If you're on Facebook, go ahead, you can send in your comments in the comment section below. And then if you're on the YouTube, I am also pulling that up right now, so that's live, so that I can see if anybody is on there asking any questions, and we're ready to go there. All right, so just like we do every Tuesday, I've got 10 problems that I'm going to go through. These 10 problems are, it's not for any specific test. Everybody keeps asking, oh, is this for the elementary, or is this for something else, middle school, high school? They're just 10 problems that really people have sent in, and then I've chosen so that it shows some tips, some tricks, some concepts that you'll be able to use while you're taking your exam. It's always good to know how to do the basics and always brush up on the basics. And that's what I do here. I don't think there's anything on here that you will encounter something in these 10 problems. I can guarantee it on any math test, okay? Whether it's just kind of at the end, the last couple steps, solving something just using algebra, or interpreting graphs and charts and those types of things. So let's go ahead and let's get this thing started. Again, if you have any questions whatsoever, throw them in the comment section. I will try and get to them as soon as I can. Usually I just get on a roll, and I'll break after the 5th question just to double check, or if I see something pop up, I will go ahead and do that. A couple things: make sure you've got your calculator. Check your exam to see what calculator you get, whether it's a scientific, a 4-function calculator, a calculator that's on the screen embedded into your test, or you may not get a calculator at all, and that's a bummer. I know there's a couple tests out there that you do not get a calculator for, and so I know I've got a problem on here. If you don't get a calculator, just kind of helping you out, go through that as well. All right, let's go ahead and get started. And there we go. Oops, that's not what I want. Hold on 1 second. Sorry about that. Okay. Sorry, you take a week off and everything kind of. Okay, here we go. All right, so our first question says, what is the equation of a line with a slope of 2/5 and a y-intercept of 0,3? So this should be a fairly common problem that you'll see on everything. And yeah, here we go. Is this for FTC general knowledge? Yes, you can use this on your general knowledge math, because some of these problems will more than likely show up. So again, that's why I do these types of problems, because they're common problems, they're commonly assessed problems, and then just trying to have you work yourselves around different shortcuts and that kind of thing. So the equation of a line that you all are going to be familiar with is this right here. Y equals mx plus b. That's a terrible x. So it's gonna take me a minute to get used to the, there we go. So I got y equals mx plus b. Now, what does all this mean? M represents slope. B represents the y-intercept. Okay. What is the y-intercept? On a graph, we have our x-axis and our y-axis. Let's say I have a line here. Here's my line. Well, where the point at which the line crosses the y-axis is the y-intercept. And you know that the y-intercept is always a 0, comma, and then that y value. So when they give us the y-intercept here as 0, 3, that 3 is our magic number. So just a quick illustration there so that you know what I'm talking about. So we just go ahead and input everything that we have. And so I've got y here. I've got the y here. Y is equal to mx plus b. And so this is interesting. I've got y is equal to 2/5 x and then plus a positive 3. And so that's my equation, right? Pretty simple, pretty straightforward. All I do is substitute my values of my slope, which is this, and my y-intercept, and put it into the form of the equation. And then I look at all the answer choices and it looks nothing like it. Okay. So why is that? Well, there's another form of the equation. It's called the standard form. And that's where it says ax plus by is equal to, I think they do C. Yeah, it's been a while since I wrote that one down. I hope that's right. I apologize if that's not, but I know anyway, you've got your X and your Y and then your value there. So let me get rid of all this. And so this is where, you know, you can get to this part here, but I'm going to show you. So I've got Y is equal to 2/5 X plus 3. What they want you to do and why they have problems like this on these tests, and again, this is a blanket statement for any math test, is to be able to understand different perspectives. I'm trying to think of another word that I can think of, but this y equals 2/5 x plus 3, there's another equation right here that is the exact same thing. It's just manipulated differently. So all we have to do is go ahead and solve this so that we have our X and our Y on the left side. So we just start moving things over. So again, you may not get a question like this, but what I would like you to do is to move the X and the Y to the left side. So this is just basic algebra. Everybody's going to have to do basic algebra on their test, period. That's what's going to happen. So I want you to move the X and the Y, and then you're not allowed to have a fraction. That's why I put the A and B, right? That's why I put the AX plus BY. You have to have a whole number. You cannot have a fraction. So with those rules, let's go ahead and move the 2/5 X over. So that's going to come over minus 2/5 X. So now I can write this as negative 2/5 X and then plus Y is equal to 3. Okay. So now does this look like anything that you see in the answer choices? No, it doesn't. And so this is why you're going to have to do the math on this one. The goal is to get this 2/5 into, and again, it's got to be positive. It's got to be positive, positive coefficients, positive whole numbers. So I've got this negative 2/5 X. So how do I go ahead and make it positive and a whole number? I've got to get rid of this 5. So if this 2 is being divided by 5, how do I stop that from happening, right? What is the the opposite operation or the inverse operation, and that's going to be multiplying. So got to get rid of the negative, got to get rid of the 5. So that means I want to multiply everything in this equation by negative 5. And so by doing that, I go ahead and this will, right, a negative times a negative is a positive, and then that stops it from being multiplied by 5. So I am just left with a positive 2x, and then negative 5 times y is going to give me negative 5y, and then negative 5 times 3 is going to give me negative 15. And you'll see now I have my coefficients are whole numbers, and then this x is positive, and that's the important one. The x has to be positive. So with that, I look at my answer choices, and lo and behold, A is the correct answer. 2x minus 5y equals negative 15. Okay. You'll see this a lot where they make you do the slope intercept form, y equals mx plus b, and then either solve it for something, just moving things around. Know how to move things around. It's very important to know how to move things around, because that's what they're going to ask you a lot on this test. Okay. All right. Question 2. It says, what is the value of the expression 3xy squared over 4 minus x squared y over 2 when x is equal to negative 1/2 and y is equal to 1/2? Okay, so I did this one 2 different ways, and the reason why I did it 2 different ways is because let's say you get this problem and you don't have a calculator. This would be a very good problem to get on one of those elementary tests that do not give you a calculator, because you're just working with fractions. So let's go through that way first. I said calculator in the beginning, and I can't remember if I said scratch paper. Make sure you've got scratch paper. The reason why I put this PDF together on, so if you printed it out, you would have 1 problem per page. So you have plenty of scratch paper to work with. When you're taking your exam, the only thing you're allowed to write on is scratch paper. You're so used to studying with a book, or you print out a paper and you're able to write the problem or work the problem underneath the actual problem, like I'm doing on the screen here. You don't get that opportunity on the test because you're looking at a screen and then doing all your work with your head down. It's a lot easier to see the problem and work underneath it than look at a screen, look down, look at a screen, look down. So you've got to get used to using scratch paper. And I know it sounds silly, but it takes time. It takes time to look up and then write down the problem. And sometimes you write down the wrong problems, or you switch something, and that is cause for a lot of problems. And the reason why some people even fail, because they think they did the problem right and they wrote a wrong number or something like to that effect. So just be careful and practice with your scratch paper, which means that I need to always rewrite everything if I need to see it. So I'm going to go ahead and rewrite this on my scratch paper. Would be 3xy squared over 4 minus x squared y over 2, knowing that x is equal to negative 1/2 and y is equal to 1/2. So let's go ahead and let's substitute everything in. I'm going to have 3, and then my x value is negative 1/2. And then my y value is 1/2 squared all over 4. And then minus my x value, negative 1/2 squared, and then a 1/2 for the y all over 2. So now I'm just going to go step by step, but I encourage you, whatever you can do in your head, go ahead and do in your head and simplify as many steps as possible. Every time you're writing something down, you're taking time. And then every time you're taking time away from a problem that you have. Even, on a 60 question test, 1 second on every single question is equivalent to a minute. And so having an extra minute at the end of the test is a matter of passing and not passing for some people, because you need to work on your time management. So the next step is to go ahead and just kind of expand this. So I'm going to have three, let's do this, 3 and my negative 1/2, and then 1/2 times 1/2, because square is 1/4, and then all over 4, and then minus my negative 1/2 squared goes to a positive. It's a positive 1/4 times 1/2 all over 2. Okay. So then let's go ahead and multiply these out. I have 3 times 1/2 and 1/4 is 1/8 all over 4, and then minus the 1/4 1/2 is again 1/8 over 2. Next, go ahead, 3 times 1/8 is 3 over 8 over 4, and then minus 1 over 8 over 2. All right. So you can cut out, maybe you do this step in your head, or you just follow it all the way in your head until you get to this step here. Okay. But whatever you do, just do it your way, the way that you feel most comfortable. All right. So now let me go ahead and get rid of all this, because I just want to go through it. I ran out of room. So you get to this point here. Okay. All right. So I've got 3/8 over 4 minus 1/8 over 2. So how do we go ahead and divide fractions? So if it's a whole number like this one is, so let me make that longer. It's 3/8 over 4, 1/8 over 2. Make these a fraction. Okay. And then all they're going to do is they're going to flip up. So when you divide fractions, you multiply the reciprocal. So this bottom number, you multiply it as a reciprocal. What does reciprocal means? It means to flip it. So this 3 over 8 is going to get multiplied by 1 over 4, right? Did you see how that comes up like that? And then this one's going to come up as a reciprocal as well. 1/8 times 1 over 2. So then we end up with 3 over 32 minus 1 over 16. We need common denominators, 32 and 16. What is the common denominator there? Well, it's going to be 32, because 2 times 16 is going to be 32. So we have that. So now it's 3 over 32 minus 2 over 32. Oh, shoot. Oh, shoot. Oh, man. I forgot that negative. It was a negative 1/2. This was a minus 3. Oops. And I already did that right there. I already erased it, and I apologize for that. But when that came down, the 3x, it was 3 minus 1/2. I think I had the line there, which screwed me up. Okay. Let me clean that up. Sorry about that, guys. It was just a line that I accidentally messed up on. It was 3, and then the minus 1/2, and then it was the 1/2 squared, which was 3. The 1/2 gave you 1/4. So it's 1/8. So it was negative 1/8, which was negative 3 over 8. Okay. Sorry about that. Don't forget that negative. You forget the negative, you botch the whole problem. And so I apologize, but watch that negative. So that was a negative. As I bring all that down, it's negative 3 over 32 minus 2 over 32. They're all the same denominator, which is over 32. What's negative 3 minus 2? That's going to be still negative 5. Negative 5 over 32 is going to give us our B. B equals negative 5 over 32. So sorry about missing that negative there, because that does make a big deal, because there is a 1 over 32, and they do that on purpose, because if you forget to square one of these negatives, like in this second part here, because it's a -1/2 squared, if you keep that negative, that'll change everything. If you make it positive, it changes everything. So apologies for that one. I really do apologize. Okay, so that's the answer for that. That's the long way. If you have a calculator, okay, so say you get a problem like this, which is not out of the ordinary, and you have the ability to use a calculator, then here's how I suggest you go about doing it. You turn them into decimals. So X now equals -0.5 and Y equals 0.5, right? So then we just roll right into it as 3 times X is -0.5. And again, watch your negatives. And then the Y is 0.5 squared all over 4, and then minus, and then we have our X squared again, -0.5 squared, and then 0.5 all over 2. Now we can just take our calculators and we get, this is going to be -0.375 over 4 minus 0.125 over 2. Okay, you just put everything in the calculator and you end up with that. And then finally go through, just hit, 0.37 divide, and you start getting, you can do a couple of different ways, but if you get all the numbers and you just keep rocking them out on your calculator, 0.9375 minus 0.625 gets you -0.15625. Now I know that looks like a lot and there's a lot of decimals there, but as you can see, if you don't like working with fractions, that's your answer. So you're just popping this in the calculator. Half the time, you don't even need to write this down. You can just have the answers ready to go. You can go from this step here all the way to this step here if you're using a calculator, because you're just doing everything in the calculator. So how do I see that this 0.15625 is -5 over 32? So the first thing you got to, the first thing you can do is this: eliminate all the ones that are positive, right? Because it's a negative answer. So this is out and this is out. So then all you got to do next is take your calculator and just say, all right, what's 1 divided by 32? And you see that it's 0.03. Well, that doesn't matter because this is supposed to be 0.15. So as soon as you see that pop up on your calculator, that's no longer the answer. Process of elimination, and the only one that's there, that's the answer. Or just go ahead, match it up. 5 divided by 32 is 0.15625. It's in your calculator. You've got the answer. That's how you go. If you answer a question in fraction form and they give you the decimal form, then that's how you do it. If it's the opposite, like this is, you get the decimal form and the answers are in fraction form, just go through each fraction and knock them out. Just divide them, get the right answer. Okay. All right. Next one. So I always like putting graphs in here because you're going to see lots of problems like this where you flip the screen, the problem pops up and it's a whole page. Like this is a whole page of stuff. And these questions are overwhelming because there's a lot of information on the screen. So I'm just here to tell you, don't fall for it. Usually these are just simple problems and it's just overwhelming to kind of scare you. It says the graph below shows the equilibrium vapor pressure, water in millimeters of mercury measured at different temperatures in degrees Celsius. This paragraph right here is just telling you in words what this graph shows. All right. You've got your x-axis and your y-axis. You've got temperature here and the vapor pressure here. Don't get overwhelmed by millimeters of mercury and, all that stuff. It's not relevant. It's just telling you what it is. the question says, if the equilibrium vapor pressure decreases from 525 to 300, by how many degrees does the temperature decrease? They're just asking you, what's the difference between 525 and 300? Well, your big numbers, right? 525 and 300 are going to be here. So you know that your answers are going to be from these numbers here. And you can see that these are going by tens. These are going by hundreds. So, more often than not, if you see this right here about 225, I'm pretty sure that's not going to work out, because look at the difference in temperature. 225 degrees, it doesn't even go up to 225. 225 is way out here. So there's no way that could ever happen. So that's gone. 90 degrees. If this were a 90-degree difference, that means it would go from here's 90 all the way to here. And I know that this is a curve, right? So that's what we're showing, but does it look like it would be the entire graph when we're focusing on the numbers 525 to 300? So here's 300 to 525. So we're focusing on this section here. So does this, let me kind of clean that up for you. So do you see how we're only focusing on this piece right here? So that's definitely not 90. And it's definitely not 75, right? Because 75 goes, a 75-degree temperature would be, even if we're at 10 and we go to 80, like that's a huge amount. And see, we're only focusing on this right here. Let me draw this from here, right? Because here's 300. So like from here, and I'm just, between the red lines is the amount. Okay. So if between the red lines is the amount, just take a look at where we would be right here. So it's definitely not 225. It's definitely not 90. It's definitely not 75. Without ever doing any math and just looking at this graph, I can tell you that the answer is A, right? Without doing anything at all, the answer is A, just by breaking it down exactly like I did. So let's go ahead and just so you see that I'm not lying to you. If I were to go from 525, they do not give you 525, right? You don't know where 525 is. Let's say 550 is here, which means half of 550 is like here. So I'm just barely over the line. So I'm right here. That's 520. We're going to say that that point is 525. So if that point is at 525, I'm looking at 90. So I'll take 90. Then 320 or 300 is here. It's this line right here. So if I go across and boom, I hit this line right here. Well, this looks like it's kind of in the middle between 70 and 80. So let's call that 75. And if I do 90 minus 75, I get 15. And lo and behold, about 15. Because you can't say it's 15 because you don't know exactly where that 525 is based off of this graph. You cannot make an accurate answer, but you can be closest. Okay. So, and that's why you have this language here. See how everyone says about? It says about here, which means it's not definite, which means you can put 15. All right. Other ways or otherwise in the question, it would say closest to, what would be the closest or something like that. So that's how you do that. Make these easier on yourself and don't get overwhelmed. All right. This is another one that I can see people getting confused on. It says the first three figures in a pattern are shown below. We have 1, 2, 3. Each box represents one square. It says which expression represents the number of small figures in figure N? And you're like, well, what is figure N? Figure N can be any figure. This is figure 1, 2, and 3, but N represents that figure. So figure 1, N would equal 1. Figure 2, so N equals 1. N equals 2. n equals 3. So how are you going to figure out the equation for this? Well, all the equations are right here. And we always want to work smarter, not harder. So that means each one of the correct equation or expression is going to work for all three of these. All three of these, the equation is going to work. The easiest one, right? Because we always want to be easy. The easiest one is going to be the number 1. So if I can do n equals 1 and get the number 1, I know I have the right equation. So let's start with A. In this case, and again, it's a matter of how fast you do it. I'm going to write every single one down so you can see it. But if you can do it in your head, then by all means, do it in your head and then move on with the problem. This is going to be 2, and then my n is equal to 1. So I have 1 minus 1, and then to the 4th power, and then plus 3. So if I do this, I get 1 minus 1 is 0. So I get 2, 0 to the 4th power plus 3. Well, 0 to any power is 0, and then 0 times any number is 0. So all of this is 0 plus 3, which is equal to, well, I'll just do the 0. All that was equal to 0 plus 3, which is equal to 3. So when I put 1 as n, I'm supposed to get 1 because that's the only square there is, but I get 3. Does that make sense? No, it doesn't. Doesn't work. If it doesn't work for 1, then there's no way it can work for any other one. So A is eliminated. Okay. And so that's what you have to do for these. You're just basically going through each one, figuring out what expression works. The next one, n squared. So that's going to be 1 squared plus, and then 1 minus 1 squared. Okay. So I have 1 squared, which is equal to 1. 1 minus 1 is 0. So that's plus 0 squared. Well, 0 to any power is 0. That's going to equal 1. Okay, that works. I'm going to tell you right now, be careful with problems like this, because we're going to see something here. So, all right, I'm going to hold off on that because that one definitely works. Let's go again and keep on going down just to make sure we're okay. So this one does work. Just want to make sure I got enough room. Let's do the next one. So I'm not going to eliminate it. I'm just going to keep it open. The next one is n plus 1. So I've got 1 plus 1 squared minus 3. And you'll see I've got 1 plus 1 is 2. So it's 2 squared minus 3, which is 4 minus 3, which equals 1. Okay, well, that equals 1, and that's 1. Well, I can't have 2 that are the same. So one of those is going to have to not work. Let's figure that out in a second. Let's make sure the other one, and again, it could be, I always use 1 just because it's the easiest one, but sometimes you run into this problem, and that's why they do it to you in these tests. So the next one is 2 and then 1 squared minus 3. Well, 1 squared is 1, and 1 times 2 is 2. 2 minus 3 equals -1. Okay, that's not going to work. Now, what I've got to do is I've got to go ahead and do it for the next one. And again, this is now 2. This is figure 2. Figure 2 should end up with 5 squares. Okay, that's what that means. That means if I use the figure 2, n equals 2, I should get the number 5. So again, I'll do 2 squared plus, and then 2 minus 1 squared. So that's 4 plus 2 minus 1 is 1. 1 squared is 1 equals 4 plus 1 equals 5. That's good. That works out. The second one, 2 plus 1 squared minus 3. 2 plus 1 is 3. 3 squared is 9. 9 minus 3 equals 6. Doesn't work. figured out B is the correct answer. So this type of problem, you're just going to have to kind of go through and run it through. This would be doing your math quickly in your head, doing it as fast as possible so that you can knock out each one of these, because more often than not, you're not going to look at these figures and say, oh, I can totally see which equation that's going to be. Just go straight to the answers and start inputting your values. In this case, the value for n. Okay, B. All right, question 5. Again, another one. This pops up. You're like, oh man, that's a lot. What should I do? I'm looking at the graph, trying to figure it out. You're trying to look at the questions. There is no question. What's going on? So Sylvia recorded the total time of her daily commute each day for the last 2 weeks. She made the graph of her data shown below. And then here's her graph. Which statement is supported by the data in the graph? So there's not really a question, like you have to use, there's a question, then you look at the graph and then you find an answer. It's which one of these answer choices is correct. So it means you got to go through each one and eliminate them until you find one that is true. So it says the mean time Sylvie took to commute is 58 minutes. So are you able to figure out what the mean time is in a graph like this? So with these types of graphs, and the name is escaping me right now, but they're done in a range. Like, see how this is 41 to 45? Well, there's 2 of them. There's 2 values in this box right here. What are those 2 values? Well, I don't know what those 2 values are. Okay, I know that 2 of those days she was in that range of 41 to 45. Because I don't know what their values are specifically, there is no way that I can figure out the mean. All right, so if you see a graph like this and you try to figure out the mean, you're not going to be able to, because it's too exact and you're not getting exact answers or numbers. And again, that's what this question is. This question is just assessing you on the properties of this graph. Okay, it's not a histogram. I don't know. I'm sorry. You have to look it up, but I forget. It's escaping me right now. So I know that A cannot be the answer. B says the mode time Sylvie took to commute is between 46 and 50. Well, how do I know that that's true, that the mode time is 46 through 50? This says I had 6 days. 6 is the most days that she's had between 46 and 50. I think if I said 45. So 46 and 50, is that the mode? No, because each one of these 6 values can be 46, 47, 48, 49, 50, and then let's say 49. Okay. And so how do I know that that's true when, if I look at this 51 to 55, what if all of them were 54, 54, 54, 54? Well, the mode here is 49. The mode here is 54. And so it's definitely not between these 2. But again, you don't know that because it's not specific. And you would know that already, that you can't find the mean, the median, or the mode when using this type of graph. So right away, gone. Okay. And then we take the next ones, and it says, Sylvie took between 71 and 75 minutes commuting for 1/5 of the total number of days. Okay, so that's something I can figure out. 1/5 of the total number of days. Well, how do I figure that out? If you look, it says that she did 2 weeks. So you could count this up, right? You count it up, you go 2, 6, 4, 1, 1, or 2 weeks is 14. So out of 14, 71 and 75, this value right here, which is 1, I have 1/14. If I do 1/14, well, obviously 1/14, does 1/14 equal 1/5? No, because I can't reduce that down any further, and I can't reduce that down any further. So that's out. So D has to be the answer. Well, if I do the work for D, And I'll just put that here just so you can see it. 0.07 and 1/5 is equal to 0.2. So yeah, so that doesn't work. The next one, 46 to 50, that's this. So I've got 6 out of 14, which is equivalent to, if I, even if I bring that down by 2, so it's going to be 3 out of 7, and 3 out of 7 is going to be 0.42. 2/5 is equal to 0.4. So yeah, so you can see that it is more than, because that's what it says, more than 2/5, and that's the answer. Okay. So don't get overwhelmed when you see these types of problems. It's real simple. You can eliminate A and B right away, and then yeah, you're gonna have to do some digging for C and D. But once you realize what it is, it's just the days on the graph over the total number of days, which is 14. Okay, so that's your answer there. Okay, that's the halfway point. Let me just double check. Everybody on YouTube is looking good. All of my Facebook people, I hope you are doing well. I don't see any comments. Okay, let's keep it moving. All right, next problem. Problem 6. It says the number of phone calls made by 10 employees in one day are listed below. There's our phone calls. When the number of phone calls of the 11th employee was recorded, the mode number of phone calls did not change, which could not be the number of calls the employee made. All right, so this is an interesting question. It's asking you, we have 10 here. There we go. What's the 11th so that the mode doesn't change? So I've got 4, 1, 2, 2, 3, 2, 3, 2. So I've got 2, 2, 2. 2 is my mode. So mode equals 2. So it says when the number of phone calls of 11 players recorded, the mode number of calls did not change. Okay, which could not be the number. So what they're saying is you could pick 3 out of these 4 numbers and the mode will not change. Find me that one number where it will make it change. Okay. So if I put a 0 in here, so if I added 0, so let's put 0 in here. Does 0 affect the mode at all? No, it doesn't, because it's the only 0 that's there, and 4 2s beats out 1 0 any day. So that can't be the answer. Let's try 2. So if we go ahead and we do 2, so I'll do another 2. When I do 2, I go from 4 2s to 5 2s. And so that doesn't change the mode. So yeah, that person could do 2 and not change. So B is out. The next one is 3. So if I did 3, what would happen if I put 3 here? So if I put 3 here, you'll see I have 1, 2, 3. Now I have 4 3s. So I have 3, 3, 3, 3, and 2, 2, 2, 2. Does the mode change? Well, the mode is still 2, but what happens when we have the same amount of numbers, which are also the most amount, right? Because there's 4 2s and 4 3s. Nothing else beats 4 of the same kind. So your mode is now 2 and 3. Yes, you're allowed to have more than one number as the mode because they're tied up. That's how that works with mode, right? The mode is 2 and 3. So if the person did 3, yeah, we're still at a 2, right? Because it's asking you which one will not change the number of calls. Then yeah, it's 2 and 3. So that's going to be our answer. That's going to be the one that the employee could not make. You can't make 3 calls because you will end up changing the mode. On the last one, obvious 5, there's no 5s. 2 is still going to be the mode, and therefore C is the correct answer. Okay. It's just people will get confused when you see 3, you got 4 3s and 4 2s, and 2 is still the mode, but it's also the mode with 3. And you can have 2 numbers as modes if they're the same amount. Okay. All right. This one here. I always like these that are in the coordinate plane because some people can get confused with it. It says, which is the perimeter of trapezoid ABCD? Okay. Okay, got a question. Number 5. I just had a question real quick pop up. Why isn't A? Okay. So for question. So the reason why you cannot have A, right? A says the mean time Sylvie took to commute is 58 minutes. All right. 58 minutes is right here somewhere, right? 56 to 58 is like right here. So number 1, the median, or I'm sorry, the mean is the average. Look at all of these numbers here. All of your numbers, most of your numbers are below 58. And so just by looking at that, your average or your mean is going to fall somewhere in between here. Okay. So that's the first part. You got to understand what average is, because see, this is an outlier here. So all of your numbers are going to pull to the left, and 58 is too far to the right to be the average. And then the second part is, this says specifically 58 minutes. Well, I want you, okay, I want you to tell me this, this says 1. Let's just do this right here. This 71 to 75, we have 1. So in one day, her commute was between 71 and 75 minutes. So tell me, what value does this represent? Is it 71, 72, 73, 74, 75? Okay, you cannot tell me based on this graph what this value is. And because you can't tell me what this value is, there's no way you're going to be able to tell me what these two are, because you don't have the exact values. All you have is a range. And that's why this graph is the way it is. See how the bars touch each other? Because it's just a range. If it were a regular bar graph and each bar had its own number, then they wouldn't be touching each other. So that's why. Okay, I hope that makes sense. All right, back to this one. Perimeter. So you can do a couple of things with this. With perimeter, we're just measuring the sides. So I'm going, let me use red because I can see red better. Okay, so I'm going from this, I'm just going to go around from point A to point B. Well, I can count each square. If you count each square, you're going to get a value. Or you can look at the coordinates, right? Because this is on the x-axis, right? It's going horizontal. So anything horizontal is the x-axis. So I've got 9 and I've got 7. So I know that if I take, subtraction is finding distance, right? So if I go, -9 minus 7, what do I get? I get -16. Well, you know that you can't have a negative number, right? That's why you would put these in absolute values, but don't worry about that. You can always subtract it. You'll always get the right answer. So this is 16. So this is a length of 16. Okay. Because I did the -9 minus 7, or I could count it, but I know that this is 16. Next, I've got this here. And again, this is going vertical, or up and down. Up and down are going to be my y-axis. So if I do 1 minus -4, right, that's going to be plus, that gives me 5. So this is a length of 5. And then again, I go here and it's the x-axis again. So it's 3 and 7. So 3 minus 7 equals -4, but distance can't be negative. So this is 4. All right. So far, I have, I'm just going to put it here. I have 16 plus 5 plus 4. And when I do that, I've got, what is that? 16 plus 9 is, I'm at 25 so far. Now, how am I going to get this value here? Okay. So let's focus on that. So you figured out how I did all of this. So now I'm going to show you how to get this. Now, here we go. I need this line here. I can't count it up because it's diagonal. So how do I figure that out? You can use the distance formula. So if you see here, Milligro said, could you use the distance formula? Absolutely. You can take the distance formula. You can take the X and the Y. Distance formula is going to be the square root of your X1, X1 minus X2 plus Y1 minus Y2 squared, right? And then go through that whole motion, and that can be a whole mess. Okay. But what you have and what you should recognize here is you have a triangle. So this point ends here, and this point ends here, and this point ends here. And so this goes from 9, and then this is the 0.3. So 9 to 3 is going to give you 12. This hasn't changed. This is 5. And so this would be your C. So you can do Pythagorean theorem. And so you would do 12 squared plus 5 squared equals C squared. 144 plus 25 equals C squared. 169 equals C squared. Square root, 13 equals C. This is now 13. 13 plus 25 equals 38. B is the correct answer. Okay. All right. So that's how you do it. Pythagorean theorem. Here's another thing. If you recognize, okay, I've done this before. Pythagorean triples. Trips. This is something that you can use on your test. Pythagorean triples are 3, 4, 5, and 5, 12, 13. They're in any variation of these. So 3, 4, 5. If you double it, that means it's going to be 6, 8, 10. If you triple it, it's going to be 9, 12, 15. All right, you get it? So when I recognize this is a 5, 12 triangle, well, the only way that I could have it is 5, 12, 13. And so what is the distance formula? Yeah. I would stay away from the distance problem in this formula, just to be honest with you. I can show it to you real quick, but I think that's going to take way too much time. The distance formula, honestly, is the Pythagorean theorem, except it's just with 2 points. Okay. So there you go. That's how you get that. If I had this problem and I counted up the perimeter, and let's say I'm at 25 already, right? If I'm at 25 already, let me show you. So I would just kind of count. I would kind of go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11-ish. Like I know it's going to be, well, you know what? I'm sorry. I shouldn't even do that. That's a bad move. What do you know about triangles? This is 12. This is 5. Your hypotenuse is always your longest leg. So this leg cannot be less than 12. So if I even did 25 plus 12, what do you get? I get 37. Well, the only one that's closest to 37 is 38. It's definitely not going to be 33 because I know it's got to be more than 12. Does that make sense? And so again, that's right. That's what I wanted to remind you on this one. You can just know if you have two sides, the two legs of a triangle, the hypotenuse is always the longest side. So you don't have to do any of that Pythagorean theorem stuff. You just count it up and say, oh, wait a second, it's got to be more than 12. Well, what if I add everything up using 12 as it, knowing that it has to be more? Well, you're never going to get to 50, 80, and it's already more than 33. So B has to be your answer. So that's how you have to kind of attack these problems. All right. Okay. Next one. We've got on a science test, Susan's score was 12 more than 2 times Jennifer's score. The sum of Susan's and Jennifer's scores is 78. How much did Jennifer score? Okay, so with these, we just want to make sure we're understanding how to develop equations and then solving. And this is going to be, it's basically a systems of equations, but not like you're thinking in your algebra or algebra 2 classes. So we got to go through and we got to make sure we write the equation correctly. So it says Susan's score was 12 more than 2 times Jennifer. So that means Susan's score is equal to 12 more than 2 times Jennifer, 2 times whatever J was. That's a 2, not a Z. Okay. So 2 times J. Yeah. We'll do this. Okay. The sum of Susan and Jennifer's score is 78. So S plus J is equal to 78. So we have to figure out, in this case, what Jennifer's score is. Since we have two variables in each equation, we've got to eliminate one of them. In order to eliminate the one that we want or figure out the one that we want to find, it's going to be Jennifer. So we got to get rid of we have to get rid of the S because we have to solve for J. Does that make sense? So solving for J, we can do this 2 different ways. In order to solve for J, we need to put whatever the S is equal to in terms of J. All right. So the way that I want to do this is, if I already know that S is equal to this right here, S is equal to this right here. So that means this value is now going to get substituted in for S. So it goes 12 plus 2J plus J is equal to 78, right? So I just substitute that in. I see that I have J's here, which is good because I need to find Jennifer's score. So go ahead and simplify. I've got 12 plus 3J is equal to 78. Take the 12 away. I have 3J is equal to 66. Divide by 3. J is equal to 22. That's it. 22 is the answer. Okay. I mean, honestly, that's called substitution. If anybody is doing a harder test and you have substitution and you also have elimination, I can show you what elimination looks like. So we need to go ahead and manipulate these equations. I want to go ahead and take this 2J, like if I did minus 2J and minus 2J, then this becomes S minus 2J is equal to 12. Okay, see how that works? So now I have these 2 equations. I have S by itself on both of them. So I need to eliminate the S. So the way I can do that is subtract. So I can subtract these 2. What if I subtracted these 2, right? This is gone because it's now the second equation. S minus S, right? There would be a 1 in front, but it doesn't matter. S minus S cancel out. Then I have J. This is 1J. So it's 1. Okay. I can put a 1 in front of here. 1 minus minus 2, which is really plus. So that's going to give me 3j equals 78 minus 12 is going to give me 66 divided by 3 divided by 3. J is equal to 22. Still the same answer. That's using what we call elimination. All right. Okay. Next one. These I always hated because it's not exact, but again, that's what you have to do. You see this type of problem on every math certification. Okay. This is a very generic type of problem where you're just estimating. Here is where a lot of people screw up. They see this, they're like, oh, I know I'm supposed to do the area, and they just start counting. Do not forget about the key. It says that each one of these squares is worth 2, not 1, but 2. So however many squares you count up, either count by 2s or multiply by 2. I'm going to multiply by 2. So whatever number I get, I'm going to do times 2. So let's count every square that we know is a full square. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So right now I have 9 times 2, which is 18. I know that I have 18, like for sure, right? So 16 is gone. Just by guessing, I know that I'm not going to get anywhere up to 32. So it's going to be between 24 and 28. And again, I have to get the closest number. So let's start putting squares together. So like a big square and a little square will count as 1. So I'll take this one and this one, and I'll count that as 1. And then I'll take these two, this one and this one, that's 2. And then maybe this one and this one is 3. And then these two right here are definitely 4. So even if I had 4, and I know it's more than, so what if I did 4 times 2 and I got 8? So what is 18 plus 8? So 18 plus 8 is going to give me 26. And so you got to be careful because I was going big on these, right? And so because I was kind of given some extra, this 26 number may be a little too big, but that's, you know, that was kind of giving it more. It's not going to make it to 28. So my closest guess is going to be B. These are difficult because you can't be exact. So I kind of overestimated, and the absolute maximum that I think, in my opinion, would be 26. But the only two numbers I have to deal with are 24 and 28. So go on the low end because I went high when I estimated. Okay. So hopefully that makes sense for you. But the biggest thing is knowing that each square is worth 2. All right. Last one. It says first 4 terms of a sequence are shown below. We got 1, 3, 9, and 27. It says which expression represents the nth term of the sequence. And so how does that work out? Oh. All right, sorry, I thought I had to sneeze there for a second. So very similar to the one problem we did at the beginning of the session where we had that n and you had to find the term. N just means what number should I get? Okay, so let's start with, you know, the number 1. So the first term, like the nth term. So you see the nth term here. This would be n equals 1, n equals 2, and so on. So let's make it easy, and we're going to focus on there. N equals 1 should equal 1. Hopefully that makes sense. So let's go right down the line. 3 to the 1, or 3 times 1 equals 3. Well, 3 is not equal to 1, so that's out. The next one is 3 to the first power, and that also equals 3. So that's not going to work out. Then we have 3, and then it's 1. So 1 minus 1. Well, what is 1 minus 1? It's 0. What is anything to the 0 power? And again, be careful of your 0 powers. Anything to the 0 power is 1. Okay, that works. Let's go for the next one. And that's really what they're assessing you on here is what is 0 power. The last one, 3, 1 plus 1 is equal to 3 squared, which is equal to 9. That doesn't work. So our answer is going to be C. More importantly, know what a 0 power does. Anything to the 0 power is equal to 1. Okay. All right. That's it. That's the 10th problem. The last slide is always the answer key. So let me just make sure nobody has any questions. Looking good here. All right. Looking good here. Okay. Oh, okay. There were some. Good job. Pass your test. Okay. Okay, cool. Excellent. All right. Doesn't look like we have any questions, compliments. Glad you. Ooh. Okay. Excellent. 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 All right. So that's it. Time flies when you're having fun, right? 1 hour goes real quick on these sessions. If you have any questions, so if you have a question about any problem that I did tonight, because this is recorded and you're just watching it now, please hit me up. Info at Kathleen, Kathleen with a K, Kathleen Jasper.com. Okay. Info at KathleenJasper.com. Our Facebook, our YouTube, Twitter, Instagram, whatever, any of our major socials, go ahead. You can hit us up in any shape or form. Anything pertaining to math will come straight to me. Everything gets forwarded to me. If you have a question, if you saw something, if you're studying, get a screenshot, do whatever you can, send it my way and I'll put it up on one of these sessions, because that's what I do. I'm here for you guys. I'm here to do the problems that you have problems with. Okay. And I want to make sure you all are getting everything you need so that you can pass this math section of your exam. It's the 28th. The 30th is right around the corner. Hopefully those of you that are signed up now, and you'll go ahead and you make it so that you can get your contract for next year. If not, then that's okay. Don't give up. You move forward and you get it next time. So if you need anything, please let us know. Hit us up on our website, on our YouTube, on anywhere that you see KathleenJasper.com. We also have other things than math, but I do the math every Tuesday at this time live. So with that being said, thank you very much for joining me. I hope I helped you out. If you need anything, please let me know. Other than that, I appreciate your time and I will see you next Tuesday.